3s2, 3p6, 4s2, 3p6, and 4p5.
1s2, 2s2, 2p6, 3s2, 3p,
3p6, 4s2,
4s2.
3p10.
Nice. Okay, so you went from 4 to 3, right? You're remembering that when you hit D block, you drop down to energy level, and then
4p10.
4p5, right? Okay. So give me a thumbs up if you made it to bromine. How many electrons should it have?
35.
There should be 35 because it's an electron number 85, or atomic number 85, meaning 35, meaning it has 35 electrons. Okay, so somebody raise their hand and tell me, how is bromine ions going to change based on bromine's initial electron configuration? Nick.
The last one would be 4p6.
Nice. So the only thing different here is that bromine, because, I'm going to get my laser here, because bromine is super, super close to noble gas electron configuration, if you want to look over here on the wall, bromine is going to choose to form an ion by going forward 1 to look like krypton by making a -1 charge, because it's really way too far for it to go back 1, 2, 3, 4, skip 5, 6, 7. So it's easier to gain 1 electron than to lose 7. Right? If it's lazy, it's going to take the shortest route. So this will be all the same, and then 4p6. So this one right here is bromine 1- because it gained 1 electron, whereas this one's just straight up bromine because it doesn't have a different number of electrons than it does protons. So how many electrons does bromine 1- have? How many electrons does bromine 1- have? So it took you a second, right? But you think 35 is original, so it has 35 electrons in the first sample. But when you gain 1 electron, you now have 36 electrons. Are you still bromine though? Right, you are still bromine. But who do you look like in terms of your electron configuration? Krypton. And so I think Nick yesterday was the one that said, yeah, we always aim to look like the electron configuration of what? The noble gas. So you're looking on the wall over here, that's group 8. What did you just read on your warm-up when you're writing down your valence electron stuff? What do they strive to do with their valence electrons? I'll let you take a second to read over that if you still need to. So Elizabeth, tell me something you found out when you wrote in the warm-up right there.
When electrons are lost or gained, ions are formed.
Okay, so the ion form, and it's not just any willy-nilly ion, right? The ion is going to meet the electron configuration that has, can you tell us? Octet. You see that O-C-T-E-T? Octet. What's octet kind of sound like? 8 valence electron. VE is valence electrons, right? Okay, so I want you guys to look at bromine, and I want you to circle, just from bromine, the valence electrons. And where are we going to find the valence electrons? Like, in terms of the numbers, 1, 2, 3, 4, and 3 and 4. Jacob, what do you think? Based on your warm-up, your little reading you were writing down. Where do the valence electrons exist in the atom? Hold on, Jacob, don't tell me yet. You guys have a minute to talk in your groups about where the valence electrons exist and circle the ones from your warm-up. You have a minute. Talk in your groups.
Also, I have 3 too. They don't know where these real lives are because they don't care how they name their names.
Alright guys, 5, 4, 3, 2, 1, back up here. Jacob. I'm ready, man. Where? Okay. Pause your conversations. Okay, great. So outermost layer. What do you mean by the outermost layer in terms of what we see up here?
4p5.
Okay, so I'm liking what I hear so far. 4, because 4 seems to be the outer shell, the 4th energy level. But is that the only thing you see 4? Where else?
4s2.
4s2. I know that's 3Ds in the middle of them, guys. But remember, it's the 4th, it's the outermost energy level. So it's the 4th energy level. And it's all of the electrons in the 4th energy level. So we got 4s2 and 4p5. So assuming you can count 2 plus 5, how many valence electrons does bromine have? 7. So this is important because you're going to be seeing this on your problem set a little bit later. But we have 7 valence electrons. Is that 8? No. How close to 8? By 1. Okay, so does that make sense now? By bromine gained 1 electron to look like krypton's electron configuration. Because now instead of having the 7 electrons it started with, it now has 8, which is octet. So the goal is to always get octet. So let's go with, was there an ion on your problem set that you want to go over? Problem set 5? That's APs. Hold on. Problem set 5 from here. Number what? 10 from here? Not yet. I want to do electron configurations first. So anything right now, guys. Speak now for over which piece? Yeah. 4C. Uranium. To F block. You subtract 2 from the energy level. Yes. Okay. We're going to go ahead and do that one real fast, okay? Uranium. Here we go. Yeah, it's going to be C right here. 4C. All right, hit beast mode here because it's going to take us a minute. Get your electron configurations out. I mean, your periodic tables out. I believe in you. We can do this. We can do this. Only because I want to show you how we hit F blocks. We didn't do an example like that yesterday. So follow your finger across. I'm going to look on the periodic table over here. 1s2. Keep going. 2s2. Shout it out. Let's go. 2p6. 3s2. 3p6. 3d10. 4p6. Stop. Where are we at? Hold on. Where are we at? Who are we at? 4p6. Krypton. Okay, we've made it to Krypton, right? Is that right? Yeah, okay. Next. 2, 4d10.
4.
Yes, okay, hold on. Pause. We went from 4p6, which was Krypton. We went across the 5th energy level. We hit D block, which was the middle from yttrium to cadmium. And then we went 5p6, which is 10. Can't read all my glasses on, guys. To xenon. So right here, 5p6 is xenon, yes?
Yeah.
Okay, then we went to 6s2, which is rubidium and strontium. I'm sorry, cesium and barium. All right, so pause here for a second. What do we do now? So we actually have to go to F block. So what's the number of barium? What's its atomic number? What is barium's atomic number? 56. I'm going to point here because I can point here. So 56 things should go to 57, and lanthium is truly number 57. Lanthium is the beginning of the F block, and then underneath that you have actinium, which is looking at the F block, the second row there. You with me?
Yeah.
Okay, so we have to now put F block in its place. Now that's the one where you did N minus 2. So we're in the 6th row, but we're not talking about the 6th energy level anymore. We're not in Kansas anymore, guys. What's the next one? 4. Okay, so you're going to 6s2, 4F what? 14, because there should be, and it really does depend on what periodic table you're looking at, but like you can see lanthium and actinium on the wall over here. It starts up here, but counting lanthium all the way to the end should be 14. Same thing for actinium, counting actinium all the way to the end should be 14. I know sometimes it's wonky, but I want you to remember the F block comes before the next sequential D block. Okay, so we got 4F14. Now we bounce out of F block. We're at like luteum or lutetium. We're not. We haven't finished. We got to do D block first, right? 5D, 10, and then right out of D block you go back to 6. So that's 6p6. Okay, and then what? Whew, 7s2, guys. We're almost done. Okay, 7s2. That gets me to radium, right?
Yeah.
Okay, so now I'm in F block again. But what's my number? 5. Okay, how many electrons over is uranium? 4. Okay, so that's 5F4. Woo! Yes, because uranium should be 4 over into that F block. How many electrons should be here? Uranium. 92. Woo! That's a big thing for like first thing in the morning, guys. Okay. Only because I love you. Well, I tell you the shortcut. There is a shortcut. Now that you've appreciated electron configurations, you got that under your belt, got one up on everybody else. Let's do a shortcut. It's called the noble gas shortcut. Noble gases, they're the cool kids, right? So look at uranium and go backwards. What's the last noble gas it has? So we were back to thorium, back to uranium, actinium, back, and you said what? Radon. Rn, radon. So here's how you do that. Oh, well, let's just bracket it off here first. Where is radon stopping here on this this electron configuration? 6p6, right? So all of this, blah, 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 is radon. Yes? So if you don't want to write all this, I mean, you totally can, guys. I'm not going to stop you. If you put bracket Rn, that means all of this. And then, just to finish off, just to get to uranium, you're going to do what? 7s2, 5f4. All right, this right here is acceptable when I say you can do the shortcut, when I say noble gas shortcut or shorthand electron configuration. If I say you must do the longhand, you got to do the big shebang here. Okay, so it's practicing both of them. Yeah.
Are we going to have a phrase to really use on the test?
Absolutely. Yes, you will always have the periodic table is your BFF. Don't lose it. Make sure you know how to use it. Question. I will not have you draw one like this because that is just way too much work. It's not that I don't think you can do it. It's just why, right? Okay, so how would you write? Oh, yeah, noble gas shortcut. Okay, so easier way. Make sure you bracket the last noble gas and then go forward. So can you guys track this out? Tell me what's this? What element is this? Argon. I know that's argon, but argon 4s2 3d10. Who is that talking about? Can you hear a table?
Zinc.
If everybody give me a thumbs up, you can see that zinc. You're going to 3d10. That's the terminal end. That is zinc. Okay? Look at argon 4s2. So argon, you're looking on the board, on the wall if you need to. Argon there, and you go forward. 4s2, that's calcium. All right, who likes the shortcut? Woo! Okay, so you can use that in your problem set as needed. When I ask you to, it's fine. Or if I don't say anything, do what you need to. If I say longhand, you got to go with longhand. Okay, so before I move on, I want you guys to do one more for me. I want you to do P3 minus. Write the electron configuration for it. Go. Raise your hand when you're done.
Phosphorus is 15. You guys already probably got that.
You're right.
Oh, I get it.
Last Caroline's going to write the electron configuration on the board. Check yourself. Phosphorus is
I can either go back 1, 2, 3, 4, 5. Because my electron from phosphorus 1, 2, 3. The end point has to be the noble gas. So you either go back 5 minutes or you go forward.
Is there a way we can go back with the whole NC? We can put the element brackets. Is that the way we can write it backwards? Like, no gas.
No. Nope, absolutely not.
Okay.
Because it's cumulative. Okay, guys, so for phosphorus, as of here, neon was our last noble gas we passed. And to go just to phosphorus, it's 3s2, 3p what?
6.
Okay, let me go just to phosphorus first. Don't go to the electrons of -3. It should be 3p3, right? But you can see here, 3 negative charge means it's gained 3 electrons, so then that's actually 3p6, right? Now, how else could I write this? Just like that. If you wrote that for me, that would be a good answer for phosphorus 3 minus. That would be fine. That's your shortcut, right? You like the shortcut? Yeah, Kellen.
Never mind.
You good?
Yeah, that's pretty good.
Okay. Let's switch modes. We gotta do one more because I have not talked to you about excited state. Do you guys remember the spectroscope lab? Yeah. So we have not finished it on there. But how did we excite the electrons so that you could see them glow? How do we excite them? We threw electrons in, right? We basically electrocuted them. And what happened when we electrocuted the electrons? They live in this ground state, right? What happens when we excite them? Jumps up to a higher energy level, and then what happens? They can't withstand, they can't stand that excited energy level. Come on, they fall back down. Now, what's so important about that falling back down part? They release energy, which happens to be in the visible spectrum that we can see. That's why we saw all those different colors. How did I tell you could also excite them? Not with electricity. Heat, right? Fire. Guess what? Doing that today. Okay? Using the Bunsen burners, we're going to catch them on fire, and we're going to see their colors. But first, let me tell you about exciting the electrons. So we saw this picture already, yes? We talked about the ways to excite them. Now, whenever you write an electron configuration, because we still need to track those electrons, when you write an electron configuration for an excited state, write this example down for yourself. An excited state, tell me it's excited, right? The electron has jumped. Has it lost or gained an electron? Yeah or nay? Has it lost or gained an electron?
No.
No, it has not. It's not an ion. You haven't done anything to it except move its electron from an inner core to an outer shell. So what is calcium's electron configuration just normally? Don't do shorthand, do longhand. 1s, 2, 2s, 2, 2p6. Where are we at right now? We're at neon. Following with me on your periodic table. 3s2, 3p6, 4s2. Okay, stop there. How many electrons should be here? 20. Don't change it. A calcium atom has 20 electrons. This is ground state, though, okay, guys? This one is ground state. We have just its normal electron configuration. So if I excite the electron, I have to take the ones that are on the valence shell. So what number is our valence shell? 4. Good. I don't know who said over here, but 4. 4 is our valence shell right here. It's the very outside shell. It's the last orbitals of electrons filled. So these electrons can be excited. So they're going to jump. They're going to jump to a higher energy level. So what's the next highest energy level? So you could jump them to a P, but I think it's easier if we just jump to a whole new energy level. 5. Okay, so instead of writing blah, 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 we're going to put all this. We're going to do the 3p6 like we did at the end. And then instead of putting 4s2, we're just going to put 5s2. I know that looks wrong to you because it's not ground state. Now what do I have here? Excited state. Now you could put the shorthand here. You totally could. And your shorthand would be what? 4s2. What's that bracket? 1 second, Caroline. Argon, right? So looking back, you're looking back at calcium. I'm on the wall if you need to look. Calcium backs up to argon. So that whole thing there could be written as argon 4s2. And that would be its ground state, right? What would its excited state be? Argon 5s2. Question? Question, Caroline, still?
Why did you put the number on the end?
Where at? This one?
No, 4s,
The 2 right here? Or this number here?
the number.
So I mean, this is just calcium's ground state. So that's calcium ending on the 4th energy level and S block the 2nd electron over. That's why. Did I answer that?
So you just bring that to a higher.
Yes. Higher energy level. So I took the 4 and I made it a 5. because that's excited now to that second orbit or next orbital. Yeah.
So if we just had Argon's ground state, would you move both 3s2 and 3p6 to the next level?
No, you only have to move one to the next level. And I chose to move 2 of the s electrons. So good point. I chose to move both of the 2 in the s orbital here to a higher state. I could, and there's like a bazillion ways to write the excited state. Really, only one has to be excited. So I could have also written it like this: Argon 4s1, meaning I left one of them in the 4s, right? And then what did I do with the other one? I did the 5s1. I can do that. I've got one electron that moved from 4s to 5s, and that's it. As long as one electron's excited, we've got an excited state. Yeah.
Is that just to represent that there's like a jump, or do you have to do it like it jumps 2 levels? You have to do
We're just going to represent an energy jump, and I always just represent one electron energy level being jumped. If you put up to 7, I'm okay with that, but you don't know for sure that can happen. We know it can jump at least 1. Maybe not all of them, but we know it can jump 1. Any more questions right now? Excited state. Okay, we're going to play electron bingo later. We're going to do flame test first. Okay, flame test is my favorite lab. Okay, and what I need you guys to do is I'm going to show you briefly how to do it. I already have a little data sheet for you. You're welcome. If you remember, what's always the first thing you're going to do when you go back to lab? Okay, goggles, what else? Shoes, and I will try to make sure we're just very careful today. I have to not say you guys are doing lab. I was going to do it Monday, and then I bounced, and I was like, I think we should do this today. It makes sense to do today. So my groups that are at the lab stations, you guys are going to stay in your spots to put your stuff under the desk for me. Okay, but when we get back there, I'm going to demonstrate how you will excite the electron. So watch me very closely. After that, you guys have sample solutions at your desk. The sample solutions at your desk have various ions in them: calcium, strontium, barium, nitrogen, or sodium, lithium, copper, iron. All these different types of metals. That's what you're going to see on your table. But lab station 1 and 2 might need to share some, or lab station 1 and 5 might need to share some because I only have so many solutions. I'm going to demonstrate how to light it. I mean, how to show you the excited state. Then after that, you guys are going to try to identify all the colors that all of these ions make. And then, so that you know what's going on, I'll give you unknown solutions. So if I give you unknown solution number 1, and it burns blue, you're going to have to see what ion that was based off your previous experience that you just had in the lab. Does that kind of make sense so far? Okay, it won't take us more than 30 minutes. Now, this is where I have my cutthroat experience. I have cleaned all of these loops that you'll be using. Don't contaminate them for my next class. So that it takes a long time to kind of make sure that they're clean, because if not, you have contamination. You can't really tell what the color is supposed to be. So just be careful. And then I want you to try to identify 3 unknowns. I have like 12. If you want to identify more just because you're having fun, I'm cool with that. Okay? So after you get done, you can try to finish up that spectroscope lab. I'll put them back on your desk, but we're going to come back here in about 30 minutes. Okay? So I need you guys to pick your lab groups in less than a minute, get your goggles on, and go to the labs. If you want to stick in the same lab group, that's fine. I'm giving it to you. 3 people to the lab group. 3 people to the lab group. Alright, you have 5 seconds to get your body to the
They wouldn't do it after like 3 times. I did it on like 30. Yeah.
2, 2, where you at? I'm asking right now. How many people are you got 3. I have some lab stations with 3. Most of us do it. You have more people. That's not allowed. Guys, grab your lab books out just in case. But I'm going to briefly walk you through the procedure. I have not put the gas on yet. Please go ahead and set your Bunsen burner now. If you do not remember how to set your Bunsen burner, then I will help you. I need to get a couple more buttons.
It is right here.
You're not working on yet. Your strikers should not be striking. I'm not supposed to
Warm up. Why do you no. I remember
I should not hear strikers going yet. I did not say to turn on, did I? Thank you. Thank you. Okay. Eyes over here. Ready? Ready? All eyes over here. Give me a thumbs up. Oh, wait, okay. Do you ever have a little flash? Okay. They're on your desk. They're on your lap. Everybody else. Okay, great. I'm going to tell you how you're going to use these loops. What you'll notice is that every single little container in your sample has a rubber banded or taped on the loop. This loop is called a nitrate wire. Do not leave this in the flame forever. It will start to burn and it'll be red hot. I don't want you to brand each other. Okay? This is not a part of like a cult. We are speaking loud. Okay? So this right here, the loop you will dip into your sample. I'm going to and I'm going to have my lovely assistant light the Bunsen burner for me. So I'm standing. Near the box bottle, yes. So I'm going to be her assistant actually. So Chloe said, first you look from the bottom, you turn the belly to the right, and then you turn it halfway, or maybe about a full turn. We don't want flamethrowers, we like our eyebrows. What's next? Do you have a spark? So I may have given her the worst spark pressure known to man. Starting this one, okay. And then you turned it 4 turns forward, 4 turns on top. She's really working on it, guys. I want to help her. Okay, so I'm going to turn it on. 3, 2, 1. We expect she's out, right? So I turn it off. So now she's going to be my partner. Turn it on for me. 1, 2, 3. Okay, so yep, keep it on. So now we have this nice, beautiful blue cone, right? Okay, I'm going to dip my sample, or open my sample without spilling it. I'm going to dip my loop in there, not all the way in there, just get a little bit. You'll have like a little sample inside of it. It's like a bubble, right?
Okay, and then you're gonna stick the loop in the inner loop cone on the side of the inner loop cone. Whoa. Okay. So you're like, oh, I didn't see that long enough. I wouldn't let it for more than like 3 or 5 seconds. If you need to get some more because the burn's off, right? It's evaporating. You do it again. You're like, oh, I didn't see that long enough. Ooh, okay. One more time. You're like, oh man, I missed it again. Okay. So, okay. This is, now look on your lab sheet. You see Cu2 plus, copper 2 plus. You see that? Okay, now most of us have, be careful please. Okay, you see the extra 2 blend spots at the bottom of the table? Put in Cu2 plus. That's copper 2 plus. What color was it? Turquoise, greenish blue, whatever you want to call it. Teal, that's fine. But I just need to make sure that you're aware that not every single solution is in your boxes. If you need to add it, add it. Okay? Now, does everybody understand what you're doing? Give me a yes. Okay, can you do that by yourself? You have 5 to 10 samples at your station. I demonstrated gluing for you. You will rubber band that loop back to the container so we don't lose it, okay? Alright, light your burners up and we'll go. Yeah, that's right. Guys, you're setting up your own Bunsen burners correctly.
What was that?
Turn it off, start again.
You ain't never gonna make me say that again. That was a perfect spot. You ready? Back again. 3, 2, 1. That's how you don't burn off fire. This isn't even on here. Oh, what? It's not even on here.
I was like, that's not good. I know, right?
Rob, you ready? Like, NO3. Rob, you want to see?
Yeah. So can I double check the settings real fast? Just because I don't know how our viewers are. I barely do that. So to me, it's low.
There we go. Let's unload the elbows. Oh, it's PA.
Alright, ladies, 5, 4, 3, 2, 1. Ladies, I do trust you, but I expect that you're not putting your hair in the fire. Pull your hair back. Because I know you're leaning over the table. Pull your hair back. You lie to protect your eyes.
Wow, that is
I just don't want you guys to ask me. You want to come over with me?
Yeah, I'm getting one this morning. It looks like it's the top. Yes, I can burn someone. Oh, who's my yeah, oh my gosh.
Okay, lab group's here. Pause for a second. Some of you guys have solutions they don't have. Vice versa. Make sure you trade buckets. Trade Angela. Do not lose my time.
What is this? I just got these, you guys so amazing. So, this is good, right? Oh my God, Rob, we need to Rob. It's so pretty. It's one of my favorites. I like it when you Rob, you need to video. Just swipe this one. Don't make me a liar. There we go.
Yeah. Back from here. I want to grab and the
Oh. That's the bad part. Where was it?
Alright, listen up. 5. I'm not gonna make you stop. Listen. 5, 4, 3, 2, 1. Thank you. So I'm now gonna start passing out a couple of unknowns. And what I might do is just put a couple here and a couple here. You guys can get one, bring it back. Get one and bring it back. Now with the unknowns, you need to identify based off your known samples, all those colors you just saw. Maybe you're not done yet. That's totally fine. You're going to think about what color you saw and match it up with the unknown. And you guys can do as many as you can do, and I'm probably going to give you about 10 more minutes, and we're going to stop, okay? So, I'm going to put this in the middle. You're free to move on to that if you're willing, and you got it ready. The unknowns are going to be in the middle, and I'll take them until you're ready.
This is it's not on hey guys, we have NACL. Wait, Robbie, you ready?
Oh, yes.
You guys have NaCl.
I just got rid of it.
Okay. You guys have NaCl.
Oh, no, we didn't. We never did do that. It's NaCl.
Yeah.
That's purple. Purple and blue. Here's that real like in here, and it's still like on fire. It's like signal. That is so cool. I love it. Oh, we get it. Wait, was this orange? It was the orange. I was thinking about Hey. I'm getting the best flames out of this. Okay? You have fun with it.
I know, right? You're like, I have the most fun out of this.
Okay, I'm gonna evaporate all this stuff. I'm gonna get more or
Next, come on, we gotta finish it. Part of the lab.
this is really cool because this is all the flames. Wait. What's Which number is that? Just say it.
That's very
I'm not gonna write down the whole name.
And Windows 6 right here, option 50 bucks.
I will buy that for 10. That's my offer. 20.
30.
5. Final offer.
Wait, which one is that? Is that a receivable one? 18
We have to mess with it. Oh, I know what you meant. That is not.
You can probably think it's probably fireworks, right? Sparky gold.
No, Windows 6.
Okay, just do number 6.
I know. We already have.
Wait, we're good for number 3?
Yeah. Oh, I know what it is.
Okay, I'm gonna give you a question.
You have about 3 more minutes to finish doing your testing. 3 more minutes.
What was that? Is that like?
I have unknown number 4.
Yeah, that was yeah, he's right there. So he's watching this.
Wait, he's watching.
I know that it's sodium.
What number is that?
Ooh, I love that one.
I put 4 in. I put
Unknown number 5.
It's gonna be very, like, this is gonna be very, it's gonna be very, so we are wrong by the exact same color. Number five. No, this is your, here, I'll show you.
It looked like he was about to jump it out to the thing. I was like, let's see, guys. So number 5 is there.
This number 1 again. Let's try this. I don't know.
Yeah, I mean, Jack.
Oh, this would be calcium. I remember calcium also being This is the reddish one.
All right, you're gonna turn your phone converters off by the time the timer goes off. Phone converters off by the time the timer goes off. I want you to finish your analysis. I'm gonna let that timer go until it annoys us. All right, all the unknowns are right. Thank you.
Oh, it's right there, Robbie's got it. Oh, right, forgot. Okay, so that's what I named it. So I think it was this one. Number 6 is fine. Yeah. Yeah, it's dangerous. We're at we can't read. He didn't let the fire make the I'm just trying to. It's so easy. And you gotta drink it like 30 Like we all had to have a connection between each other. Yeah, it was like it wasn't hard at all. We have more people. The other two like the same part. Wait, no. We're telling them that this spirit cycle. Yeah, it was
back to our seats shortly.
That was crazy.
Guys, here's what I'm gonna do. We have about 15 minutes left. Listening. I was gonna let's play electron configuration bingo, but I feel pretty good about you guys in your electron configuration. So I'm gonna go ahead and hand back that spectroscope lab. You guys will finish your plane test analysis and your spectroscope analysis. You have the spectroscope still at your station if you need to look at things, okay? So if you need to go back to your desk to grab the spectroscope analysis or your lab, do so. Catch up when they start. I mean, right now.
Probably we know who
It's over back. Oh, I have the references. Or you guys are, or you can go grab them. They're right there. Alright, you have 12 minutes to get both of these labs as best as you can accomplish.
No, I guess. Well, it's gonna take place, but I think it's gonna drink one. And what is it? That needs a meeting because you got to the way to so it's not going to. Oh, when you show a place why do we
I see your hand. I'm coming.
so much number? I got math. Yeah, I lost you. Oh I'll show you. Yeah. I wonder why. Wait, it's 4.6. Oh, you found the previous. You used to wait on what's the wait Why is it negative translate? Bro, you're eating something on the side. Anyway. So is it going to make the same? How far did we even get on? You guys yeah, I'm looking it up.
Yeah, I was I did a short time and then no one did it. Sex calls is never ended.
Yeah,
Yeah,
I was never in that group chat. I was never in the group chat.
I was, but then yeah, I remember Mrs.
Well, Nick did it for that.
Okay, you got
Guys that did it.
there's another.
Anyway, turn this on. Anything fall because of the fact that there's a light what is this called? Purple is 1.4. Also orange. Turquoise is
I'll say two.
oh
Wait, two is what?
Look at mine. No. Okay, so for this, here, pretty, this is where we go. This is where we go. I Gary did all the calculations on the point. The different two calculations are wrong. Here's the first one. No, I can't. Oh,
Alright guys, take 1 more minute after lab. Go ahead and clean up your lab stations so that my next group knows what's going on.
Alright, you should be coming back to your seats. That one should be done.
Oh wait, we are tuning in?
Lane test lab in the box. 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 Bobby, don't worry about it. Lane test lab in the box.
I thought it was on like
It's the half sheet one. I'll see you back in your seats before the bell rings so we can dismiss you.
Whoa, man. I don't even have question 1 done.
Lane test lab in the box.
Dang. I have no
I'll see you
idea.
back in your seats in 5. 4. Margaret, take your glasses off. Hey, look, good girl, let me know. 3. In the inbox. 2.
I'm waiting.
Oh, all right. Homework. Look on the board. Finish PS5. You shouldn't have much left to do. Read Guide 6 is next tomorrow. We're talking. We're switching notes. Finish Concept 5. You don't have much left of. You reading Guide 6. You waited on Concept 5. You got a long way ahead.
I haven't done my video with you guys.
Okay, guys. You guys can pass by your own. I don't have my own. I have real quick.
Yeah. What's up, Rachel? What's up, Rachel?